Hey guys, we're going to be looking at a couple of problems today. Hopefully not too time consuming, no promises, but I'll see if I can keep my word here of at least under 10 minutes. So let's zoom through here. Alright. We're going to be looking at a problem. Find the minimum and maximum value of f of x, then state the domain in range. Okay. Sounds kind of cumbersome, but with your notes from yesterday, and here's a review of those notes. Okay, I want you guys to kind of look at it one more time. So you guys we covered vertex, a couple of those features. Vertex is really important because it's really a simple concept, right? If you didn't catch on to it the other day, okay, the vertex is really the either minimum or maximum on a parabola. So if you look at this as an ice cream, right, the bottom of the ice cream is the minimum. If you look at a mountain, the top of the mountain is the maximum. All right. Now, once you've established that, there's some characteristics that apply, and we're going to use these to respond. So let's go and get started here. So to find the minimum or maximum, okay, then state the domain in range of the function. So the first thing that needs to come up is, hey, is this thing facing up or down? Okay, does it open upward or downward? Right. So because here I noticed that, and let's stick to our guns like we did in class here. Okay. What I'm going to observe is that I have a equal to 1, right? This is from our previous lesson, and c equals to -6. All right. As you guys remember, opening upward or downward is determined by this coefficient up here in the front, and because a is positive, okay, then we have it opening upward. Okay, so instead of writing the words opens upward, I'm actually drawing one facing up. Now, because of that, you'll notice then that there would be a vertex here on the bottom, which everything else would be on top, so this would be a minimum. Okay, so that's the second thing, is that we want to declare this as having a minimum. Okay, minimum. Why? Because it's facing up. There's a point at the very bottom. These arrows show it goes up forever, but down will not go forever. This is the minimum. All right. With that said, okay, find the minimum. So what is it? Okay, 3. What is it? Well, we need to identify the vertex. So let's go through that process. Right. We need -b over 2a. This is again review. Then f of -b over 2a. Alright. Now, before we would already have had x coordinate done, but now we have to do both of these coordinates at the same time. No big deal. So let's go ahead and do that. Okay. So this part right here, okay, is -b over 2a. If I substitute, I've got -2 over 2a. A is 1. That's 2 over 2, and I've got 1. Done. Okay? So we'll call that the first part of 3. The second part of 3 means I now have to take f of this, right? -b over 2a, which really just equals f of, because we've already determined it is equal to 1. So now I can, alright, so let's see here, we have f of 1, and let me plug in this function here. Okay, so where all the x's are, I'm going to be putting in a 1. Okay, so x squared, right, minus 2x, whoops, minus 2x minus 6, and I'll put in a 1 there and a 1 there. Now I can go ahead and do the math. So I've got 1 minus 2 minus 6 equals -7. Okay, so now I have that my vertex is xy, right? Or in other words, 1 and -7. 1 and -7. Okay, and while we're at it, this is indeed your x coordinate. You can check that from your notes from yesterday. and this is f of x, or another name for it is y as an equation. Alright, so that takes care of that. We're 5 minutes in, so let's go and continue here. Let me just make sure we answered everything. So anyways, we found it had a minimum. Okay, I think we went the distance to identify what it was. Okay, so technically here's the vertex, and the minimum occurs at, let me put that on here, minimum at -7. Okay, so that's as low as it goes, right? It's your y coordinate up and down, so this is the furthest down it goes. And state the domain in range. So that's not that bad because of our notes, which tells us we had a minimum, okay, that the domain is all real numbers. So let's put that on here. So the domain, okay, we'll say is all the element of all x such that x is an element of all real numbers. Well, you're going to see this a lot, so might as well just copy it and memorize it. And as far as the range goes, look what it says, minimum. The range is all the values greater than or equal to the minimum. Okay, so greater than or equal to. Alright, so let's use the same notation. So the range is all the y's such that y, or excuse me, all the y's are greater than or equal to what? -7. Okay. Again, this is set builder notation. We've seen it in the past, so there's your refresher. Jot it down. If you have questions, ask tomorrow. Let's move on here. Alright, these next ones, let me go ahead and just give you a quick little tip here. Okay, besides your routine vocabulary work, here's something you want to know, something you have to know, is that whenever you hear the word zero, find the zeros, find the roots, find the solutions. What else is there? I'm missing one here, but anyways, this should be sufficient for now. The zeros, root, solutions, if I remember the one, I'll come back, but they all mean the same thing. So if you're asked to do any of these three, it's the same process. Okay, so here we go. Find the zeros of the function by factoring. So we're going to look at this trinomial here. Okay, we're going to factor it out the way we have. And if you kind of forgot, look back at our videos on factoring, okay? But long story short, this is what it comes down to, okay? It's been factored. So how do you find the zeros? Set each one of these equal to 0. So check this out. Okay, you set this trinomial equal to 0, and you investigate. Where does that happen? Where this one equals 0, or where this one equals 0. And if you do the quick math, right, you subtract 20 to both sides, you got x equals -20, and x equals -3. And in case I went a little too fast, this is all I did, right? Very basic Algebra 1 stuff, just kind of solve for x. So these are my two zeros, okay? All right, a little more of the same. Find the roots, okay? Now this one's put in different order, so check this out. Let me rewrite it here. Equals 5x squared. All I have to do is rewrite it, so I'm going to subtract 5x squared. Okay. Now, sometimes you want to avoid having a negative up front. I guess in this case it doesn't matter. I'll just continue. Okay. But I could have subtracted these two, but we'll stick to our guns here. So now if I rewrite it, check this out. I have -5x squared plus 30x minus 45. This cancels, so I'm left with 0. Now, okay, I can go and factor this out. Check this one out. This is a nice review. I'm going to take out the greatest common factor, so I got -5, which leaves me x squared, minus 6x, right? This times this gives me a positive 30, be careful. And this gives me a positive 9. This times this gives me a -45 equals 0. Okay, next, what I'm going to do is I'm going to factor this like we've done in the past. So I get x minus 3, x minus 3 equals 0. And I'm ready to solve for 0. So here, the first thing I would do is I would multiply by, or excuse me, divide by -5. Alright, really quick trick. Anytime you have 0 comes in very handy, so I'm left with x minus 3. X minus 3 equals 0. And like before, now I have to set each one of these equal to 0. Okay, which is redundant, but I'm just making a case. You solve for them, and it turns out that x equals 3. X equals 3. Why? Because to solve for x, you simply add 3 to both sides. Okay, so about long story short, x equals 3 is what works here. Alright, so I've hit the 10-minute mark. So let me see this next one. This one, if you don't mind, I'll take a quick minute here. This was not that bad because if the zeros are given to you, okay, the roots, the solutions, this is all this means. It means that you could come in here, put in, I should do it this way. And if I hit 12 minutes, I absolutely will turn this thing off, so I have x, okay. And if I was to plug this in here, I would have x plus 8 and x minus 6 in here, okay. Now, if this one's not clear, we definitely want to explore that in the class. For now, this should be sufficient, guys. Thanks for your time and enjoy your day.